right, this video is going to be pretty brief. All I'm doing is going through activity B on dehydration synthesis. So hopefully you've already looked at your video for activity A. If you have not done that yet, you can find the activity A help video in the Dropbox for this assignment. So let's move on to activity B. Activity B says we're going to get the gizmo ready by making sure we're on the dehydration tab up here at the top. So make sure that we've clicked over, we've done create glucose for activity A, we're on activity B for dehydration. The first question on our lab guide is talking about glucose being an example of a monosaccharide, which is the simplest type of carbohydrate, and a disaccharide is made from bonding two monosaccharides together. What do you think the prefixes mono and di mean? Well, I'm going to tell you right now, it represents an amount, okay? So the prefix mono, what does it mean? What does the prefix di mean? If you don't know, go Google it. It helps to learn. Number 2 is asking you to make a prediction. It says to turn on show description. So you want to check this box right here. Nothing's going to happen yet. And then what you're going to do is you're going to drag both of these glucose molecules into this workspace. Okay. And then it asks us to observe this highlighted region. Notice we have an oxygen, 2 carbons, and 4 hydrogen atoms here. Okay. It asks you to make a prediction. What do you think is going to happen to the atoms in this region when the glucose molecules bond together? So remember, this process, synthesis, is bonding together. So we took these 2 glucose molecules. Here's where the bonding site is occurring. What's going to happen with these elements? Remember what happens, remember what I talked about for activity A, how many bonds each element wants to make. Remember, carbon only wants to make 4. Oxygen wants to make 2, and hydrogen wants to make 1. Well, oxygen right here is already binding to a lot of things. So what's going to happen here? You need to make a prediction. So go ahead and do that. Pause the video and make a prediction. I cannot mark you wrong on making a prediction, so just take a quick guess. Once you're ready to continue, you're going to run the gizmo by clicking continue. And you'll see that the animation has synthesized or pushed these 2 glucose molecules together to combine them to create a new molecule, okay? It asks what was removed from the glucose molecules when they bonded to form maltose. So this molecule right here, this big molecule now that it's connected, is called maltose. It's asking what was removed, which is this one single thing up here. Well, if you're not sure what this is, it's got 1 oxygen and 2 hydrogens. So H2O, what is that? Make sure you put that in for number 3. Number 4 asks us to infer, based on what we've seen, create a balanced equation for the dehydration synthesis reaction. Remember that the formula for glucose is C6H12O6, and you need to determine the formula of maltose yourself. So I'm going to kind of pull over our lab document here so that we can see this in real time. And we're going to actually put our balanced equation together. Now, remember, we have not really covered a balanced equation, but an equation is an equation nonetheless. 2 plus 3 equals 5. So we're making an equation very similarly to that, only this time we're using actual molecules in place of numbers. So in this case, we took 2 glucose molecules, which we saw here, 2 glucose molecules, and we formed one larger molecule called maltose. So how can we put that in an equation form? Okay, so that's what we're going to be trying to do right here. So I know I have 2 glucose molecules that I started with. So I'm going to take my formula, or my formula for glucose, C6H12O6, and I'm going to do a plus sign. Oh, it's not letting me. Got to get creative here. Okay, C6H12O6, so 2 of those combined together, so they added together, okay? I have to be fancy with how I'm doing this. Okay, there we go. Sorry, I know the formatting is not the easiest, but there's always a workaround. Okay, so we have glucose plus glucose equals maltose. So remember though, when we built that, when the new molecule was built, it lost water. So we're going to have 2 less hydrogens and 1 less oxygen at the end. And all we have to do is add these together. So I'm going to go ahead and it's going to be C12 because 6 plus 6 is 12 for those carbons. Hydrogens, if I just add these here, that would be 24. And then oxygens would also be 12. However, like I said, we lost a water molecule. So one water molecule was 2 hydrogens. So instead of 24, it should be 22. Remember, we lost 2 hydrogens and 1 oxygen to H2O. So that would be my equation here, would be C6H12O6 plus C6H12O6 yields C12H22O11. Okay? And then don't forget your water molecule. So not only did we get a maltose, we got a water. So then I'm going to put H2O as well. There we go. That is your balanced equation for number 4. If you want to know if you're right or if you didn't know how to do this, one way you could figure this out would be to click show current formula and it gives you the formula right there. The last thing that you need to do is summarize what you've observed to explain what occurs in a dehydration synthesis reaction. So using what you just watched, okay, all you do is have to put it in words. 2 glucose molecules joined together, water was released, a new bigger molecule in the form of maltose was formed. Boom, activity B done. Great job. You can go to the next video for activity C once it's available.